Let's talk about VTP next. This is enough to understand. This is a proprietary protocol of Cisco. We don't use it very much in the enterprise network now. Except for exams. When you are preparing for the exam in the future, we'll send you the document. Just enter 3 commands when you face. This thing is not very important. VTP is called Virtual LAN Trunk Protocol. It is used to create VLANs in batches. You can see. There is a server here. There is a client. Indicates that this is a CS architecture. If there are many switches in the enterprise. Assuming 100 switches. But what if you have 1000 VLANs? Too much work. You have to manually create 1000 VLANs on these 100 devices. Then we can now choose a switch as server. Others are treated as client. I configure VLAN on this server. Then sync to other devices. Reduce workload. We'll get to that later. Cross-VLAN intercommunication between Layer 3 VLANs. Let me briefly talk about how to configure it. It's enough for everyone to understand. First we enable VTP. I change a VTP mode. It changed to server. It changed to client. They assign a password to each other. Name each other. It creates VLAN here. It can be seen here. This thing is not needed now. For the client. It cannot create VLANs by itself. Only it can create. Okay. We're done talking about VLANs. Then we look at the next requirements. Actually, VLAN can divide the broadcast domain. That is, there is no communication between different VLANs. Neither unicast nor broadcast. But it also limits the ability of the host to communicate at layer 2. After we divide the VLAN hosts between different VLANs, there is no way to communicate with each other on the second floor. They are not mutually imitable. So I just told you. For the entire VLAN. It's more about wanting to isolate broadcast traffic. And to differentiate and isolate overall data. For example, for different departments, I can rely on VLANs to differentiate different traffic. Make it impossible for them to complete mutual visits. But in fact, in our daily practical application, there will also be a need for mutual visits between hosts. We tend to be more. Treat VLAN as a means of security isolation. But usually, sometimes we also want to exchange visits between hosts. That is, I hope the host unicast can still communicate. We want more to suppress its ability to broadcast. Therefore, the VLAN we refer to hopes to make it unreachable between the 2 layers. But we hope that there is still communication between the 3 layers. That is, we want the 2 hosts to be in different VLANs. However, it is still possible to communicate data. Switch-based networking. Isolation of broadcast traffic through VLAN. Then by itself it can narrow down the scope of the broadcast domain. What if unicast communication is desired between devices across VLANs? Can't it work? That is to say, we hope to realize layer 2 broadcast failure. But it is hoped that unicast between different VLANs can be communicated at other levels. If we want to discuss the issue of unicast, we also discuss on the second floor. Neither unicast nor broadcast. If I want the host to communicate now, it can only communicate across network segments. That is to say, only rely on the switch to query the MAC address table. Corresponding VLAN. Corresponding interface. Forward accordingly. This is not working anymore. You can't complete the communication. So now we can only communicate across network segments. If communicating across network segments, it is known. Access as a host across network segments. is looking for a gateway. The gateway helps it communicate across network segments. Then we have to mention devices such as routers. Wait a minute, I will introduce a router. We will use a representation of a router across network segments. Routing table. Everyone should be familiar with this. But we all know. Now this is the basic forwarding of some addresses. We can find gateways across network segments. Then the router directly looks up the table and forwards. But now there are more VLANs. How can we communicate with each other on top of VLAN? This is called mutual access between VLANs. Inter-VLAN access needs to use the routing function between different VLANs. There is no way to communicate on the second floor. If you want to communicate, it can only be forwarded with the help of three-layer query routing table. So, we can achieve, even after deploying VLAN, we can still communicate across network segments. This is an effect we want to achieve. It has several ways to implement. One of the easiest ways. This thing is not commonly used. Called one physical connection per VLAN. Let's see how it goes. The PC on the left is assigned to VLAN 2. This is an access interface. Belongs to VLAN 2. The right side is divided into VLAN 3. This is an access interface. Belongs to VLAN 3. Router as a layer 3 device. Its interface is a layer 3 interface by default. It has no way to process data carrying VLAN tag. So the switch is connected to this interface of the router. It must also be an access interface. These two must also be access interfaces. So how do host A communicate with host B? They cross VLAN. I can choose a method. Is to configure the access interface on both ends of the switch. And both of them are VLAN 2. Both of them are VLAN 3. As a different VLAN. Under normal circumstances, I now send a broadcast data. So broadcast data comes in here first. Can go out here. Get to the router interface here. Router interface does not forward broadcast traffic. So the broadcast data will be isolated here. So this data can't reach here. Secondly, if I send a broadcast data. So here you go. Mark VLAN tag 2. Then it has no way to send out from VLAN tag 3. So this data cannot reach host B. I want to send a data in the future. If it is a broadcast data then, in fact, it can only be circulated in the entire VLAN. I can't send it to host B. Because it is isolated by VLAN. These two interfaces are on different network segments. You have to distinguish this. If we want to communicate at layer 3. To use routing. A router is two interfaces and two network segments. So the two of them are not on the same network segment. Assume that host B is in the 1.0 network segment. Host A is the 2.0 network segment. Host B wants to access host A. Layer 2 communication between different VLANs is definitely not possible. So it has to go 3 floors. Layer 3 traffic must reach the router. Let's talk about the process. Traffic sent here. The interface of access is marked with tag 3. And go from here with 3. This is an access interface. Come out, strip off 3. Then go into the router here. So what the router receives is a complete data. Go to the 2.0 network segment in the future. RA queries the local routing table. It is found that the 2.0 network segment is sent from the local interface. The next hop is this interface of host A. It comes out. It also sends out a blank data frame. Go here and put VLAN tag 2. Come out from here and remove VLAN tag 2. Then send to host A here. That is, all interfaces are access interfaces. Only the switch is configured here. Both of these are tag 3. Both of these are tag 2. Tag 3 and remove tag 3 here. Tag 2 and remove tag 2 here. When the final data passes through these devices are blank, it can isolate the communication between the hosts at the second layer and help them communicate at layer 3. But you will find a problem. When we are communicating at layer 3, these two hosts actually cross the network segment.